Our product called Amped On Friction. It's basically a computer accessory that acts as a ramp, and it acts as a measurement tool for students to see a ball going down the ramp when we put different materials on it at different angles. It goes on the back of a laptop, and it's also attached to a go-go board, which helps with our agent-based modeling. So now it's on the back of the computer, and we have to create different degrees to measure the angles. So we've created these little sticks that can be placed at the corner of the laptop screen that help create the angles down here. So this corresponds to a 60-degree angle, which is written on the straw. Then we have one that corresponds to 45 degrees, and then one that corresponds to 30 degrees. We also have 4 different materials which students can place inside the ramp and velcro it onto the sides that will affect the friction coefficient. So now we're showing a demo of how to use the product and how to understand the kinetic coefficient of friction. We've decided to work with the 30-degree angle first, so we placed the angle at the top of the laptop screen, and then we placed the sandpaper in as our material, velcroing it to the side. At the top and the bottom are start and go sensors. So the process that we use, first we click Set Up Reel on the model. And then second, as soon as we do that, we click Go Reel, and we press the marble down at the base, and then as soon as it lets go, it starts the timer, and then as soon as it hits the bottom, it's going to stop the timer. So I drop it, and it hits the bottom. So now that records an elapsed time. So now we have a model that we used 30 degrees, so we changed the ramp incline to 30 degrees. The real elapsed time reads 0.52, and we want to set up a model and play around with the kinetic friction coefficient to see which kinetic friction coefficient will match the elapsed time of 0.52. So we click Go, the ball drops. It's 0.28, so let's probably increase the kinetic friction coefficient. Set the model again, Go. It's 0.35, so maybe a little bit more. And we click Go. 0.52. So the kinetic friction coefficient is 0.5 here, and it matches the real time that's elapsed, which is also 0.52. So we're going to go back to our worksheet that we created. So all of these components together, with comparing the real-world model and asking students to play around to find the coefficient of friction in the computer-based model, allows them to see the patterns that will help them infer the properties of friction.